Welcome to FEA Journeys, an FEA Academy podcast dedicated to sharing the experiences of seasoned engineers who have achieved success through finite element analysis. In this podcast, we will focus on highlighting the personal stories and the professional path within the FEA domain, catering to both aspiring and experienced engineers interested in exploring practical applications and achievements in FEA. In this podcast, you're going to hear individuals from different sectors of the FEA industry, including FEA software company, FEA consultant, companies that design their own products using FEA, and companies offering engineering services. These interviews will showcase diverse backgrounds and career journeys within the FEA field. For this episode of FEA Journeys, we speak with Larry Pearce. Larry has been an application engineer with Hexagon Manufacturing Intelligence, formerly MSC Software, for over 33 years. So let's hear what insights and expertise Larry has to share with us about his specialty as an application engineer. Hi Larry, thank you very much for joining the episode of FEA Journey today. I'm very excited to talk with you. As I told you before we joined, I'm pretty sure that you have a lot of very good advice to share with the audience. Thank you for being there.
Oh, thank you for having me. So
let's start this interview, Larry. You've had an incredible career as an application engineer, especially in the FEA software industry. So let's start from the beginning. Every career journey has a starting point, and there is often a spark that ignites the passion for one's profession. What inspired you to pursue a career as an application engineer? And I mean, how did your journey in this field begin?
so there's really kind of two starting points. There's the whole finite element industry. I can share that story as well. But as far as being an application engineer, at the time I became one, I was working in Huntsville, Alabama for some subcontractors to NASA Marshall Space Flight Center. I considered myself a stress guy because I was doing hand calculations and some finite element work with Nastran at the time. And the opportunity to be an application engineer came up. And the thing that interested me the most about it is the fact that I would actually get to teach classes in the software. I had gone to graduate school, I had been a teaching assistant, and I really enjoyed that role. And I enjoyed being a stress person as well. But the part about the application engineer that really just kind of was, and I think this is unusual. I wanted to actually participate in training classes. And an application engineer, just for people that don't know, you wear a lot of hats. So, we are typically the people that before someone buys the software, we kind of help figure out, what are the needs and requirements and whether the software has the capabilities to meet those. We also do post-sale support, like answering questions, helping install the software, debug problems, and teaching classes falls into that arena as well. Product enhancements as well as product testing. So there's a lot of different things that we do. The teaching part is a small part, but that's actually the part that drew me or was of interest to me to be an application engineer.
Okay, I see. That's very good. So when you say you are a stress person, I think we have to explain the audience what we mean by that compared to an FEA engineer. Can you clarify when you said a stress engineer?
So it was my job to calculate the margins of safety for failure, which could be lots of different modes of failure. It could just be as simple as writing a margin of safety for tension or versus shear. We might include, random analysis in that, but we would come up with some factor of safety. So my first job out of school, as the quote stress person, was working once again as a subcontractor for NASA Marshall Space Flight Center. And the company I worked for, our job was the space lab that flew in the shuttle cargo
Okay,
bay.
cool, cool.
Space lab was European Space Agency had designed it and built it, but our role was to make sure that the space lab did not harm the orbiter, and also the stuff that was going to go in it, because you could think of this as like, I kind of view it as a weekend version of the space station, because you could go
Okay.
up and you stay up a week and then you come down and you've got science, right? And the space lab had two parts. It had a module which people could inhabit, and it also had a pallet which sat outside and exposed things to the elements. That's where I worked. I did the pallet work. And once again, we just wrote margins of safety by hand. Interestingly enough, we had a finite element model of the pallet. It was a very coarse stick and panel model. But we would run that model and determine loads, and then use those loads to do some hand calculations for stress. To tell you how old this was, today's finite element analysis, you would clearly have some beautiful color fringe plots, right? We had nothing like that, right? So we would look at the text output on printed paper, by the way, and we would find the highest load and then the member that corresponded to that load, and we had some black and white drawings, and we would pull out our handy dandy little template and draw a little circle around the element that was going to be the one that had the highest load, and that would be the one that we calculated the margin against.
Okay,
So,
I see. So the space lab was your first experience as an engineer, correct?
absolutely was my first
Okay.
experience.
Oh, so,
And
yeah,
anyway, I'm
go
sorry.
ahead. Go ahead. Go ahead.
No, and I got to do some finite element work there, but I did not get to build the model. I actually never knew. It's been so long ago. I think the model was probably developed by ESA and just
Okay.
delivered as part of the deliverable. And
Okay.
once again, it was very coarse. You wouldn't have looked at stresses out of it. It was really just to determine loads and load
Okay,
paths.
a load model to, okay, for the load path,
Hmm.
and okay, I see, I see. So, how did that initial experience shape your understanding and passion for this field? Even if you say, okay, it was a very simple FEM, but I'm curious to know how it shaped your understanding and for this field.
No, that's a super good question. And that actually traces back to how I found out about finite element analysis in the first place. I was in school, I went to Auburn University, and I had, strength of materials, engineering mechanics classes, and I had learned how to do beam problems. I knew a little bit about pressure vessels, and I began to think, I know how to do something, right? Somebody might hire me to do this. And I was walking by a pressure vessel that was there in the engineering buildings. It was actually a pressure vessel for the wind tunnel for the aerospace engineers. And I looked at it and I go, I can do that. But then I looked closer and I saw there was lots of supporting structure. There were lots of nozzles going in and out. And I just thought, my simple understanding is really not enough to do this. I've
Yeah.
never seen anything like this. And so I asked a professor, you know, is there more? And he said, clearly there's more. And he pointed to plate theory as like a two-dimensional version of sort of beam theory, right? And he pointed out that there was a lot of things that we could do by hand, but there was going to be some things that we didn't have a closed form solution to. And that's the first I ever heard of finite element analysis. It was not, whereas today, some
Sure.
level of finite element analysis is part of many engineering classes. At the time, it was part of none. But we did have a class. I took it. I learned about shape functions and stuff like that. And so my job was the first time that I got to run Nastran. And,
Okay.
once again, I just wanted to do more of that. It, and what's the great about it is many people want to do it because you get those color fringe plots. I didn't even get those. I just like the fact that I could, um, get the load distribution, load follow stiffness. I could get that very accurately, that
Absolutely.
and look at many, many load cases, which would be typically beyond what I would have done by hand, right?
Sure, sure.
So that's what led me down this path.
Yeah,
So
yeah. Oh, very interesting. Thank you for sharing. So I would like to come back now, or to focus, I should say, on your path in the FEA software industry, because it has been quite diverse and extensive, this path. You've held multiple roles over the years that have contributed to your expertise and influence. Could you walk us through your career path within this industry? I mean, the FEA software industry as an application engineer, the different roles you've taken on, and also how each of these roles has shaped your knowledge and skills as an application engineer.
excellent question. So once again, an application engineer wears a lot of different hats, doing demonstrations, discovery for a pre-sales role, a post-sales role, answering questions. Every application engineer that I've worked with, you come into this industry with some background knowledge. We've all got an engineering degree. We've worked in industry for a while. I consider that real work. I consider it real work to write a margin of safety. And as an application engineer, I haven't written a margin of safety or written a stress report in a very, very long time. Um, but so we come into the job with some knowledge of either finite elements or some level of structural analysis or dynamic analysis. What I find really interesting about the job is what we learn from that point on typically is driven by what the customers ask us.
Mm.
So, I mean, when people ask me questions about, for instance, doing composites with Nastran, clearly I'm going to do a lot of homework. I'm going to ask a lot of questions so that I can respond to them and help them be the best that they can be. It could be optimization. It could be a number of things, but I find that application engineers bring something into the job, but then we grow once we're here. And the growth is typically in response to what I need to share with a customer from a pre-sales perspective, or what I need to share with a customer from a post-sales perspective as well.
Yeah,
So,
yeah.
mhm.
Yeah, that's very interesting. I like this aspect that you mentioned, the fact that you interact with a wide variety of customers, and you have to adapt to their needs and answer their questions. So, and I like the word homework. When you said homework, you have to do your homework to help them. I presume that it permits you learning many new stuff, new domain. Correct?
Absolutely. And, as I thought about, us talking today, I really did kind of think about that, because if I had remained just the stress person, which is fine, that would have been my focus. And I'm sure I would have grown and I would have done things there. But as an application engineer, I've got to do things I would have never done. I might have
Mm.
never got to do optimization.
Yeah, yeah,
Uh, I don't consider myself a dynamicist because I did not perform that function um, in what I would call the real world. But as an application engineer, I get to delve into that, right? I get to look in many areas that I might not have had the opportunity to before. And once again, that's primarily driven by what I need to know and what I need to do homework on in
yeah,
response to the customers. And you will find, so this is another interesting thing. So you will find that not all application engineers know the same thing, right?
yeah,
Clearly, once again, most of us come into the role with a certain baseline amount of knowledge, but then once again, we each kind of go in different paths based on the homework we have to do to support our customers. And I was involved in a benchmark many years ago, and I remember there was two parts to it. There was two questions on composites, and I got to answer one of the questions, and one of my colleagues got to answer another. And they were really the same question, but they were kind of packaged a little differently. And I answered A, and my colleague answered B. And we were asked in the debrief, well, which answer is it? It can't be both. It can't be A or B. Which answer's right? And I said, my answer. And not to dish on my colleague, but it goes back to what I say. We often know more about the things that customers have asked us, and that had actually been something that I had been asked in the past and had to do some research on. So I knew my answer was right. So
Yeah. That's cool. That's cool. And yeah, in my mind, it is the powerful of the role of application engineer is to guide the customer who has a real problem, to guide them into the software to permit them building the simulation corresponding to their reality. That's a really cool role, I presume. Thank you for sharing that, Larry. Very, very interesting. Uh, Personally, I am a user of the MSC product, the Nastran, Patran, Apex, and very often I see the name of Larry Pearce when there is a script developed behind the scene. This script developed by Larry. If you have questions, please call Larry Pearce. He calls Larry Pearce every time. So your work at PDA MSC Hexagon, especially in scripting, is very well known in the industry. So one project that many listeners might be curious about, it is the Rootman Fastener script. A Rootman the script I'm using a lot, to be honest, personally in Patran and a little bit in Apex, but more in Patran. For those unfamiliar, could you start by explaining what the Rootman Fastener is and why it's significant? Then tell us how you got involved in developing the script for it and what that process was like.
great question. I'm glad you asked that. So first, I need to say that yes, my name is on a lot of scripts, but you left out the most important part. You send questions, comments, and Elvis sightings to me.
Yeah.
Yeah, exactly. I get Elvis sightings all over the world. He seems to hang out in pubs in Europe more than anywhere else. So he's still around. So the Rutman Fastener was, you know, the methodology, the Nastran parts, the Nastran bits and pieces was originally by Dr. Alexander Rutman.
Mhm.
At the time was Boeing. He was working with a colleague. I believe his name was Adrian Viscerano. I may be mispronouncing his last name. I apologize. Later, they became Spirit of Wichita, and Chris Boschers was another colleague that worked with Dr. Rutman.
Mhm.
And the Rutman Fastener, prior to the Rutman Fastener, a lot of models that were modeled is the shell structure would be coplanar, and it would be spring elements to represent the fastener, and the stiffness of the springs would be calculated with, I'll call it a magic formula, such as the Huth formula, or
Yeah.
something that would be validated with tests. And most of those configurations were really limited to single shear and double shear, and the modeling of all of this structure was actually evolving so that instead of things being coplanar, which honestly takes a lot of work to make it coplanar in many cases, because geometry was coming from CAD that was real geometry, that was solid
Mhm.
geometry. So it made a lot more sense to actually put the surfaces at the midplanes, let's say, or an
Mhm.
outer mold line. And so this whole idea of connecting with the springs suddenly wasn't really going to be as good as it needed to be. And so Dr. Rutman came up with the idea that, we're actually going to model the fastener with bar elements. We're going to model the bearing between the fastener and the shell structure with bushings. We're going to account for things like, keeping the fastener like plane sections remaining plane for like small deformation and things like that, and really move beyond single double shear, but to look at stacks that have more than that as well. I mean, he basically created a complete plate fastener system for the joint. Where I came in is this was much more involved than the traditional method of just having some springs. You suddenly had bar elements, you had bushing elements for the bearing, there were other rigid elements to kind of keep the joint intact. It would be many finite elements that represented the joint. And it was really begging for automation to create it. The original script was written by a colleague of mine, John Parody, actually. He did a great job, but he was new to scripting. He kind of took that on as a task to learn scripting in Patran at the time,
Okay.
get his name on the paper as well. And he did a great job, but the thing that it lacked was performance because he didn't know the ins and outs of Patran scripting to make it go fast. That's
Okay.
where I came in, to make it faster, to make that script faster. And then Dr. Ruttman continued the work. The initial work was just shell elements. We then did shell elements with gaps between them so that you could have opening and closing of the joint. He eventually included solid elements, and I provided the support in terms of the Patran PCL for all of those additions that kept going. And what's interesting, the Ruttman fastener, the earliest paper I have is 2000, but I've been at a customer site and somebody showed me something like from the late 90s. So I know it's been around for a long time. It was the first fastener that I personally saw that was like that. There may have been others, but that's the first one that I saw that incorporated all of these different elements to attempt to get a better representation of
Absolutely.
the joint.
Absolutely.
Since then, I see a lot more of that. Once again, I get to work with a lot of companies, and I see. I would call it the Ruttman fastener on steroids, where they're basically taking that basic idea, but they're improving on it for their benefits. Maybe their fastener's a little bit different. Maybe they have some test data that shows something a little different, but they kind of, once again, take that basic idea and they've kind of extended it. So it's really an exciting thing. I was so glad to be part of that work, and it continues to be widely used today.
Sure,
So.
sure. Yeah, yeah. Personally, in the aerospace industry, in composite, we are using it a lot. And as you said, it's a very powerful method because we capture for complex joint, we capture the correct behavior. And the beauty of this Rudman fastener modeling technique, I like it especially because it uses existing element from the library of element. As you said, it uses the bushes, which are springs, the bar element, the MPCs, which are existing elements connected together in order to model the joint. That's very, very elegant.
I think the Ruttman is just a great, I mean, especially in aerospace modeling in general, it's all about the behavior of the structure. It's,
Yes.
using the finite elements to match the behavior of the structure. Is it just
Correct.
carrying shear? Is it just carrying bending? And I think the Ruttman is a great example of, once again, trying to represent the behavior of the joint as accurately as possible and to give better answers so that people can write better margins of safety, get better distribution of the load in the structure, et cetera.
Yeah, 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 yeah.
I think it's a great example of that.
Yeah, yeah. And to me, it's not a black box because you understand what is connected, you understand what the bar is doing, what the bush is doing, what the MPC is doing to guarantee the compatibility of displacement. Because as I said, it is based on existing elements from the library of elements. So it's a really cool modeling technique. I love it.
Yeah.
So let's talk a little bit about the what I call the joy of empowering others. You had the opportunity to work closely with a lot of aerospace companies, helping them leverage FEA tools effectively. So this kind of collaboration often brings unique insights and experiences. You see what I mean? Can you share with us about how these interactions shaped your career and what it has been like to empower others to succeed with FEA software.
So what's interesting about that is that's my favorite part of my job. You know,
Good.
I get to work with really cool software, okay?
Mhm.
Color pictures, the fringe plots. I don't have to write margins of safety or stress reports, but I get to help other people. And once again, the software is the cool part, but the helping other people and empowering them, as you say, is the part that brings the most job satisfaction. When I think about the interaction that I've had, one, it benefits me because I learn a lot by osmosis. As people ask me questions and as I get to, peer into their world, I get to learn more about finite element analysis and structural analysis than I might have ever learned if I was just working in one particular field. And the thing I've noticed about a lot of the people that I work with who, once again, they're always doing finite element analysis because we're a finite element analysis company and they're asking questions in that regard. I find that they're excellent at the finite element part. I also find they are excellent engineers. You
Mm.
know, that's what makes them good, right? Because they understand so much and the finite element analysis just becomes a tool to give them an answer that they couldn't easily get the other way.
Yeah.
As far as me empowering other people, it kind of goes back to, once again, the reason I love this job so much is the part about getting to teach, right? And as I think about that, and I think about all the people that I have taught classes to, I wish I actually had kept track through the years how many different individuals I've had in my classes. But I can think of one company in particular that several of the people that were in my Patran class, Patran 301, they're now the vice presidents. Okay. They're like running the show. And that is because, not because I taught them Patran, right? But is because they were excellent engineers, right? And they were
Mhm.
able to leverage the tools to excel in their career, to kind of elevate themselves. I kind of look at that and I think, wow, I'm still an application engineer. I'm not a vice president, but I'm where I need to be. This is the job I like. This is the role I like, and I like being able to, once again,
Yeah.
um, help others. And another kind of story related to that as well is one customer. They had a model, they had a problem, and they needed to generate a model really fast. And they wanted to be able to distribute the work, have multiple people work on multiple pieces, but then clearly those would have to be joined together. They recognized that that is often a time consuming part to
Sure.
integrate things together. They had learned about Nastran glue technology, but it was new to them. And they said, "Hey, Larry, can you help us set this up? Can you spend half a day with us and just go over the ins and outs?" And it's just another example of empowering people, right? In other words, they're excellent engineers. They know exactly what they're looking for. They just need to know which knob to turn sometimes.
Yeah.
And that's the part I like about what I do.
Ah, cool. Great sharing. Yeah, yeah. So cool. Thank you for that, Larry. That's very inspiring. So as we know, the world of FEA software has seen amazing evolution over the years. So as someone who has witnessed this transformation up close, how have these tools evolved and what enhancements do you believe have been the most transformative for the industry?
That's a really heavy question
Yeah.
because when I started, there was no pre-post at my first job. We actually submitted the jobs at night. We couldn't run them during the day. We had to submit the job actually with cards. That's
Mm.
old school. And you know, at the time, if we made a mistake, it cost us a day because we could only run it at night, right? Matter of fact, the computer, my cell phone is probably more powerful than the computer we were running Nastran on at the time.
Yeah.
So, today, finite element analysis, although people still run it because jobs get bigger and they're still running on HPC systems and such as that, but for many people, it's a desktop app. And for me, once again, coming from a world where we could only submit them at night, cost us a day if we made a mistake. The fact that it's a desktop app, I get almost immediate feedback if there's a problem with the model that I missed. So I think that's the first thing for me personally. I also look at, um, the kinds of things that we can reliably do with finite element and analysis now. So whether it be nonlinear simulation, which would have been unheard of 30 years ago or would have been very limited. At the time, it would have been experts only, and you still need a high degree of expertise to do it. But it has been the burden there has come down some, so that more people can run light nonlinear jobs without having the extensive knowledge. I look at things like optimization, and what that does. I mean, that would have been a dream goal 30 years ago. Now it's pretty much commonplace that people optimize things. And I
Yeah.
also look at, because of my experience in the pre and post world, I just look at how far pre and post has come as well. Once again, the original stick and panel model that I worked on, that model was probably created by hand by typing it in. Okay. Today, you bring in the geometry, you idealize the geometry, you mesh the geometry, and you expect more than just forces. You expect to get stresses now that might be meaningful in many cases. So
Yeah.
yeah, the world has really evolved, and it's really exciting. It is so
Sure.
exciting. People are so, once again, it's commonplace today to run many jobs during
Yeah.
the day right on your laptop, but years ago that was not so. And
Yeah.
people don't, I appreciate it so much more than others because I've been on the other side of things. So,
Yeah. 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 I think it's easier for us now compared to your period because, as you said, you had only one chance. Yeah. If you missed it, you have to redo and wait for another day or 2 days. And now it's easier because if we miss something, we correct it, we resubmit the job in few minutes. We have the answer. Uh, I think now we are less smart than at your period where you had to think about. I remember 25 years ago when I started as a young engineer, I was working with an engineer who worked on the Concorde in Europe, and he told me exactly what you said. He, he had only three, four load cases, a pressure case, an up bending, a down bending, a landing case. Okay, that's it. And he submitted the job, and it took one week to have the results. There was no interfaces, only a pile of papers with the numbers. So those engineers were very smart because they had to think about the result before to submit the job. Okay, now it's easier for us, and we are very lucky. But on the other hand, you're right. We have the chance to run linear analysis, buckling analysis, nonlinear model. We have more capabilities. We extract more from the solution. And that's completely true.
you are correct.
Yeah. So it leads me to talk about a related topic, the the FEA software industry, as we said, continues to evolve rapidly with new trends and technologies. From your perspective, what current trends in this industry do you find most exciting and promising? What should what should we be looking for?
So I'm excited, and this has actually been a trend that's been going on for a few years, but you know, I just love the fact that simulation continues to get more and more real.
Mm,
People are able to actually do simulations that come very close to matching tests, and that is awesome, I think. Models continue to get more detailed. Once again, looking at nonlinear simulations. Years ago, you would have gotten a force somewhere near the bolt pattern, and you would have used that one force to then look at all the fasteners. But now, once again, with things like the Ruttman fastener, we model all the fasteners in many of the detail models that we're looking at. And that, once again, this trend has been going on, but I find it to be very exciting. And I think even go on more. It's going to continue to get more real. When I look at some things that are happening in the industry that I'm always excited about, I'm totally into things that have to do with optimization. I love optimization. Artificial intelligence is coming alongside of the engineering work and is providing the ability to answer some questions that might not have been easily answered before. Some people view that as, you know, taking the place of experience. I don't view that as that. I just view that once again as another tool. As engineers, we're always working with numbers that there's some approximation or assumptions in. And what makes you a good engineer is to be able to use the numbers from the analysis with approximations and assumptions, but actually make it real and make it a number that you can trust and you can write a margin about. So I see all these things coming together, and I'm excited for what that's going to mean for the structures of the future, because I think they're going to be even better and more robust as a result of our ability to analyze and to explore much more than we did in the past. So
Yeah,
that's the thing I'm most excited about.
yeah, so true. Yeah, thank you for that. No journey is complete without mentors and guides along the way. So, have there been any mentors who played a crucial role in your development within the FEA software industry or in the FEA domain in general? Okay. And what specific guidance or advice did they provide that was especially valuable to you for your development as an engineer in FEA?
So I had a lot of people, colleagues and customers as well. And, they've just given me a lot of insight into using Nastran or Patran or MSC Apex, um, you know, helping me to debug a model that I couldn't get to run. They provided a lot of patience as well, because many times I would ask the same question year after year after year, which is not very good. Um, but yeah, I've had a lot of people, mostly colleagues. I could give you names. Many of them have retired now. I miss them. Actually, one of them I did ask a question of recently, and they even in retirement, they answered my question. As a matter of fact, I asked a question about a script that they had written. They
Okay.
actually found the script. They actually said that they didn't think the script was as good as they had wanted to leave it. They actually modified it. They're retired, and they actually modified it so it would be better. And I so appreciate that from all of those people. So I have had a lot of people. I could name names. Maybe I shouldn't do that.
Oh
But
yeah, I think it's a good idea.
you think
It's
so?
yeah,
Okay.
I think it's a good
I
one.
think these names are names that people have used MSC software in the past. They will
Mm,
recognize these names. That would be
mm-hmm.
like Jim Swan,
Yeah,
DMAP, Dynamics, Mohan Barbella, everything Dynamics, everything random. I ask him the same random question every year, and he was always gracious and answered. Lance Proctor,
oh yeah,
also
sure.
Dynamics, Jack Castro, Sanjay
Oh,
Patel. Sanjay's not retired yet. He's still working. Ken Walker. Ken's actually the person that modified the script in retirement.
okay.
Don Graff, Dean Bellinger. All these people were, they've all retired now, except for Sanjay. Even some current colleagues that I work with, like Jim Leadham. Jim and I have been working together for 30 years. We both started with PDA,
Mm-hmm.
Hanson Chang and James Fillen. So these are all people that I know that they help fill the gaps of the things that I don't know, the things that I have forgotten. And, we've
Wow.
always formed a really good team. So,
Yeah. A
yeah.
lot of very famous names here. Thank you for sharing that. I'm pre- I'm convinced that mentoring is fundamental, not only in our domain, in every domain. uh, I think mentoring is very important, and it brings everyone at another level, working with the people who share knowledge, advice, guidance. Yeah, thank you for that. Many of our listeners are students or engineers aspiring to build a career in FEA. Based on your extensive experience, what advice would you give to them? What skills, experiences, or mindsets do you believe are most critical for success in the field of FEA?
So the best people at finite element analysis are the best engineers. That's what I have always found. They know how to honestly know the answer before they build the finite element model because they're able to relate the physical structure and they know what the answer should be or they know what the trend should be. They can't
Mm,
quite get the number maybe. And so the finite element analysis helps them get the number. I think that it's always the fundamentals. When you're learning something new in finite element analysis, always start with a problem that you know the answer to. My favorite's a cantilever beam. So every time I do something that's a little bit new to me, I always build a cantilever beam and I try to see how what I'm trying to learn, how what I'm trying to do, how that
yeah,
relates to an answer that I can calculate by hand. Um, Simpler is always better. I do see people that just sometimes want to solve the real problem
yeah,
without doing the homework first. And that almost always leads to an answer that you don't quite understand.
correct.
And so the more you can relate your finite element analysis to a problem that you know the answer to, that will allow you to relate the finite element results to a problem that you don't necessarily know the answer to.
Sure.
So I think simpler is always better. So to be better at finite element analysis, just simply be a better engineer. Know your dynamics if you're a dynamicist. Know your, stress and strain if you're a stress guy like myself, and other things as well. So that is the number one thing. And I can say that with assuredness because once again, the people that I know that are the best at using Nastran, they're honestly the best engineers too. So
Yeah.
um, yeah.
Yeah. Great advice. I love when you say simpler is better. Yeah,
Mhm.
it's so true in this domain in order to learn the right things. And to summarize what you say, so to be an engineer, uh, it's like uh, relying on our engineering judgment. I think it's very important when we do finite element analysis. Personally, when the finite element analysis does not give the result I expect with my engineering judgment, I always trust my engineering judgment because as engineers, we are always right and not the software. We have to make sure that the software is aligned with our engineering judgment. So that's a great advice, Larry. Thank you
Hmm.
for sharing that.
Right.
So time is running. I'm going to conclude this interview with my last question. Working in the FEA software industry is not just about professional achievements. It's also contributes to personal growth. How has your career in this field shaped you personally and professionally, and what keeps you passionate, about continuing to push boundaries in this industry?
So I think it kind of came out earlier. I have a job that I love, and I think the best part of my job is helping people. That's where I get the most job satisfaction. I also get to work with cool technology. Um, I get to make graphs that are fun for me to make, but I don't have to present them, right? So I don't have to
Hmm.
do a margin of safety and stand up in front of people and um, tell them that, yes, this is the margin of safety and have them question my material properties or something like that. No stress reports. So it is the helping people. It's also something that I could have never imagined growing up in the state of Alabama, going to, a small high school out in the middle of nowhere, out in the country. I could not imagine the other benefit of what I do, and I think is also a personal growth thing, is I know people all over the world.
Hmm.
And that has been a true blessing in my life, to know people in different parts of the world. I'm so thankful they speak English because I unfortunately don't speak their language. But it has been great to A, answer questions, and B, ask a question and have them. It's a great world that we live in, that, you can sit in a home office and yet communicate with people in Sweden or in Europe or in Japan or in China, India.
Mm.
I communicate with people in those areas honestly weekly, and that has been something that makes me feel good about the job that I have, because it's helped me to grow personally. I get to learn more about people in other parts of the world and the way they think, and what do they enjoy doing, right? So
Yeah,
they play soccer or cricket, so not United States football, but that's okay. Yeah,
yeah.
that's all right. It's fun.
Oh, that's good. Yeah, yeah. Helping people all over the world. It is your job.
Yes.
Amazing, amazing.
Hmm.
That's really cool.
Yeah.
Thank you for sharing that with us today, Larry. It's very valuable for the audience. I'm pretty sure. Thanks again, and I'm pretty sure that we're going to talk again in the future. And have a nice day. Bye bye.
Thank you, Dominic. Bye.
Bye.